Okay, so based for the question of when should the energy be delivered, that's what I said. It could be a very complex mechanism, right? Or it could be as simple as just switching on a light bulb by using a mechanical switch, okay? Or it could be as complex as using a whole IoT embedded system stuff. Is that okay? Actually, we'll be building something similar to what we have here. So be building something similar to this. Okay, so yeah, don't worry. So as a circuit designer, like I said, you have to pay attention to all these things. Okay, very very important. Now the next question that we have to answer is how frequently should the energy be delivered? Is that okay? Like I said earlier, there are times where um, the load only needs the energy in pulses, okay, or intermittently, okay. For instance, when a driver is driving, he doesn't always turn on the traffic indicator. Is that okay? That thing that switches on and off and on and off, or even the wiper, right? The driver uses the wiper when the screen is not clean. Is that okay? Or it's raining and he wants to see. Okay, and you realize that the wiper, per its operation, it has to be energized. The energy is taken off, powered again, right? So in this case, it is some form of pulsed. The energy is pulsed. Is that okay? And this is actually also very very important thing that you need to consider. Is that okay? Right. So these kind of things that we are talking about here, I've realized that many people don't actually get this foundation right. Okay, so sometimes people call me and they ask certain questions, and I just realize that it's just because of a foundational issue. Okay, people don't really pay attention to some of these things, but from my experience, the more foundation, the better your foundation, the better your understanding of these things, right? Because I've worked on many projects where I had to come back to the foundation to the first principle to solve that problem. Okay, so please, these things I'm going to spend some time talking about this basic concept. I need you to really give it your attention. Okay, it's very very important. Okay, so circuit designer is not just about being a circuit designer is not just about, oh, okay, I have this, I've connected wires. No, it goes beyond just the physical connection. In fact, at a point you even have to consider the economics of whatever you are doing. Okay, and there are even times where politics will even play a role, right? I don't know, I think recently Apple was forced to use type C. I think it's a type C USB for Europe, right? All these things are politics, right? Exactly. So the work of a circuit designer just goes beyond just connecting wires to stuff and causing them to work. Is that okay? Very, very important. Okay. So let us also look at some of the specific constraints that we may face as circuit designers. Okay. Now, the there are certain things called external constraints or standards. Okay, now let me probably take them one by one. For external constraint, it could be a safety regulation issue or an environmental consideration. Is that okay? Or if you are building your system for an industry, then we have industry standards. For instance, if you are working on systems for electric vehicles, then we have components that are termed as or that are designed for automotive, right? We call them the automotive grade component. It means that you cannot just use any component. You have to make sure that that component is rated for automotives, right? Now, why is this so? This is because, you know, you take a vehicle for instance, the heating, the movement and all that. So the components that you are using should be able to handle all these stresses. Is that okay? So in this case, if I'm designing a system for, let's say, an electric vehicle application, they have to pay attention to these things. Is that okay? So environment can also play a role. If your work is supposed to be for an outdoor, then you have to also make sure it is watertight, because you know moisture doesn't do well with electronic system. I remember I worked on some traffic lights some years ago, And I failed to actually consider these things. Oh God, every week I had to go and service the traffic light because sometimes it will turn off because animals, some insects are making molds on it. Sometimes spiders, moisture, a whole lot. I had to always service the systems every week, and it was really terrible, right? So these are things that if you don't consider, they will end up disgracing you. Okay, now aside these environmental things, there are also what we call the standard. Now standards are something like regulations or accepted uh, should I say conditions, right? That your system is supposed to meet. Is that okay? So, like I said, if you are designing your system for an automotive, then it should meet the automotive standard. And I think IPC has standards for almost anything that you would want to do. Is that okay? There are standards for electronic systems that have to be used for medical purposes. Okay, there are in fact there are grades. We have class A, class B, class C. There are standards for devices, electronic devices that are used for military and defense. Is that okay? So you cannot just build things. Cannot just build things in a vacuum. You have to make sure that you are paying attention to all these things, because in the end, if you don't pay attention to these things, then your reliability performance is going to be affected. And just imagine you spend so much money uh, engineering a device, and for let's say US, you get there and they reject it because it's not obeying or adhering to the standards, then you that will be your loss. Is that okay? So like I said, the job of the electronic system designer is not just about connecting circuit, it goes beyond that. Now the next question that I want us to look at is the question of why do we design circuits? Is that okay? So based on all these things that we have talked about, why do we design circuits? So briefly, we know that energy sources such as batteries generate what? Electrical energy. Is that okay? Now, this electrical energy is stored in something called electric field. I know most of you might have heard about what an electric field is. Don't worry if you don't. There is a chapter on it that I'll talk about it. Okay. Now, for this energy to move, okay, when we say that we are moving energy from the source to the load, you see, we need what we call electric field and magnetic field actions for this to happen. Okay, we cannot we cannot move energy if we only have electric field, and we cannot move energy if we only have magnetic field. The two of them have to work together. Is that okay? So that's what we call an electromagnetic system. Take light for instance, right? Light energy is made up of an electric field component moving at perpendicular to a magnetic field component. So anytime electric energy is to be moved, both electric field and magnetic field have to be what there. Okay. So when we design circuits, all that we are trying to do is to harness this energy to do some useful electrical work, such as switching on a light, creating motion, pumping water, and all that. Is that okay? So basically, that is why we design circuit. We move energy from the source to a load to do something. Okay. Now that thing we are doing because it is helpful. Okay, like switching on the lights, switching on the air condition, switching on a pump, whatever that we do. Is that okay? And then through the circuit, we don't just power the system, we are also able to control it, direct the energy where, when, how it should flow. Is that okay? That's what makes electronics powerful. Within electronics, we are able to manipulate the energy. Okay, it doesn't just do things on its own. We have that ability to manipulate it to the extent that we are even able to tell the extent that how much of it should flow through where. Is that okay? So electronics is really powerful, and these are the reasons why we want to build electronic systems. Is that okay? Very important. Now, this is my little advice for those of you who are beginners, right? Little advice. Now, I need you to remember the fact that electronics is both a science and an art. Okay, And like every art, mastery comes with practice and continuous learning. I mean, if somebody is learning how to dance, you don't sit down and watch people dancing. You watch people dance and dance with the people. Is that okay? So if you really want to do electronics, you can't just be a passive learner. Your learning has to be an active one. You should practice. Okay, very, very important. Now, another thing is that, and you have to be patient. Very, very important. You have to be very, very patient. Trust me, even now, I still meet challenges that takes me days to solve. Okay, if you I have something I call beginners impatience, right? Mostly when people see the things that I do, they want to learn overnight and be able to do exactly what I'm doing. Look, I have been doing these things since 2008, and even still I'm not perfect, right? I still come across issues. I build systems that have challenges, right? These let me show you a couple of stuff that I have. Okay, probably after this I'll just show you. Okay, you build systems that you have to do some tweaking to get them working. These things are normal. Even the big companies, Apple and the Samsung, they all go through these things, right? I don't know if you heard. I think not quite. I think a while ago, Samsung had to recall their S7 from the market because it was what, catching fire, something like that. I mean, that is what I heard, right? So even if Samsung is getting this issue, then just imagine you a beginner, okay? So just be patient with yourself, okay? Just make sure that you stay persistent and view the challenges that you meet as opportunities to learn and improve yourself, okay? Now, one of the other thing that I would like to stress about is the fact that you need to build a strong foundation. Look, I have seen many people who start electronics and they want to be connecting PIR sensors with Arduino and write some code to do some blinking, write some code to move a robot. Look, that won't take you far. It will take you somewhere, right? But it won't take you far. If you really want to do electronics, start from the analog zone. Okay? Learn the basic concept of electronics. Learn about the component. Learn. In fact, don't just learn. Practice. Tweak. Move them around. Just connect them on the PCB. Whatever you are doing, make sure you are getting to know the foundation. Because you see, once your foundation is solid, trust me, it is so easy for you to build on. Okay? Even physically, if you are putting up a mansion, and you want to build something like a 10-story building, the foundational work that you have to do alone can build like 2 houses. Okay, so if you really want to go far, please make sure you are paying attention to the foundation, because without the foundation you would always get up there and still be found wanting. Very, very important. Now, don't waste time trying to do impressive projects. Okay, start with basic projects, simple project. Even if it is how to switch on an LED, okay, so that you can know, okay, if I use this amount of current, this will burn. Even if that is all you have to do, please just do it. Okay, don't waste your time trying to do cool things. Okay, those things will come later. When you're able to build a very good foundation, trust me, right, it gets to a point, people tell me about their problem or the project they are doing, and automatically in my mind, my brain is solving the problem. I know those who are software developers already, you can understand. You see a user interface somewhere and your mind is already showing you how to do it. Is that okay? That kind of level is something that you can achieve if you build a very strong foundation. Very, very important. And as a physicist, trust me, I cannot stress the importance of foundation very much. You really need it. Okay, don't rush the process. Now, also make sure that you have hands-on experience. Use breadboards. And even fortunately right now we have simulation softwares that you can download for free. Get them, use them, make sure whatever you are doing, you are experiencing the electronics. Okay, you are not just being a passive learner. Okay, I've shared this with a lot of people, and those who took the advice, they are doing awesome things in electronics. Those who didn't, they still call me every day asking about how to do basic stuff. Okay, so please, I don't want you to end up like that. So pay heed to the things that I'm saying. Okay, like I said, there are a lot of simulation tools on the market, free ones, and LT Spice is a free simulation tool. Can use it without any payment. Just get your hands dirty. Is that okay? Very, very important. Now, another thing that comes in very handy, another skill that you need is learning how to read component data sheet. I think in the course of the training, I'll show you how to read a few of them, right? But learn how to, okay? Because every IC, every component that you would use, the manufacturer will give you the information about that component through the components data sheet. Is that okay? So your ability to extract the information you need would help you to create your circuit for that component. Is that okay? Basically, that is that. Explore the different circuit configuration. You see, anytime you want to build a circuit, there are always at least two ways you can do that. Make sure you know your options, weigh them, see which of them meets the purpose that for which you are creating your circuit, okay, and choose the best one. Now remember that, and I need this to always be in your mind, as a circuit designer, efficiency is always a must. Okay, efficiency is always a must. Now I should say that there are instances where efficiency is not really a problem, right? We just want things to work, but for most of the time, efficiency is a must. So always make sure you know the various configurations to perform a particular task, okay, and you select the ideal or the best one. Learn from your mistakes. Okay, that's me. If I'm telling you the number of components I have burned, the number of times I have to move up and down because I keep burning stuff, okay. One day, I think on Friday, I'll share my journey with you, just to inspire you, okay. Share my journey with you. You know that the things I can do right now, it did not come on a silver platter, okay. I've spent so much sleepless night, so much time, so much energy to get where I am right now, okay? And fortunately for you, you don't have to go through all the things I went through. That is why I'm doing this training, so that I can guide you that don't pass here, okay? So you step on my shoulders to build your foundation, okay? That is why we learn from people. So learn from your mistakes and make sure you stay updated. Day in and day out, things keep changing. In fact, if you go and check the datasheet for ESP32, you will see NRND, something like that. The NRND, NRNC, not recommended for new designs. Yes. The moment you see this, then it means that that particular IC has been upgraded. Is that okay? So components, and especially ICs, they keep upgrading them. Technology keep changing, making things more efficient and versatile. You have to make sure you keep up to date, okay? Don't be staying in the old ways, okay? New things come with better functionality, better efficiency, which will make your work super, okay? So always make sure, and then join online communities, okay? There are a lot of online communities, Discords, Stack Overflow, even my own platforms, PCB Africa, Tech Foundation Africa, okay? We talk about electronics, people ask questions, people answer them, we organize trainings, we bring resource persons into the hood, they teach, okay? You learn from people. In fact, when you learn, you see, one of the things I love about online communities is that you learn different ways of doing the same thing, okay? I mean, we all can learn something and everybody will do it differently. So in the end, if you share ideas with other people, you get to learn things from different perspectives, which is very, very important. In fact, I cannot stress that its importance that much, okay? Very, very important. Is that okay? Because online communities will expose you to a lot of experienced designers and even beginners, okay? And help you solve your problems. Now, you never stop learning. because a thinker is a thinker. I wish you all happy tinkering.